So the target is today to go through this energy efficiency in the built environment and our Finnish perspective on that. So as Lasse already mentioned, so built environment is really responsible of the huge energy consumption and resource consumption and also like emissions, both directly and indirectly due to our living and urban areas. But the good news is there that the economic mitigation potential are also greatest in the building sector. So that's the good news, that it's actually, even though it's not cheap to do something, but it's cheaper than in the, for example, energy supply systems and power plants. If you think about our Finnish targets, so we have the Kyoto targets, then we have the EU 2020 targets, and then we have our own national targets. So the Finnish EU targets, that means that we need to increase the share of renewable up to 38% by 2020 and also increase the energy efficiency. But then we have like even more ambitious target by ourselves by year 2050, where we want to reduce our national emissions by 80%. And just to give you the perspective, so the red line shows where we are now, and then you see where it ends by 2050. So it's really ambitious and challenging target for us. When we think about this, then the sustainability and eco-efficiency, so the hardcore of the whole sustainability is the eco-efficient and communities. So basically, less input materials and energy to urban and built environment, and that ends up, of course, to less carbon and less emissions. Well, rather easy to say in that way, but to make it real happen, so it's quite complicated. Basically, how we think it is that land use is one of the major key factors, so meaning that we need to have high efficiency, mixed areas, daily services should be close, and also land use is really closely connected to efficient transport. So they are really, I mean, you cannot really talk those separately. And then, of course, we have the energy side, so means that we have the energy efficient use of energy in the buildings, and then the efficient production and supply networks. As Lasse mentioned already in the previous presentations of the urban structure, so we have been speaking a lot and thinking and trying to make the urban structure dense and effective. But what has happened is actually the opposite. We always had some excuse or some reasons why it's actually scattering all the time. And this just shows you, this is a picture from my colleague Pekka Lahti, which is actually done together with Syke, so Lasse's colleagues, this study. So this shows our major cities, and the red dotted line, so those cities which are above that line means that they have urban sprawl, and then there is two cities which are below that line, so they are not like having urban sprawl, and actually the other one is only because of they changed the statistics. So that's really like kind of, we still have a lot of things to do if we want to achieve our goals. Well, transport, I'm not expert in transport, but just some words about this transport. So it's of course the land use and the urban form is important, but also like what kind of alternatives we have there. So as this is a picture showing emissions and vehicle occupancy, so how they are dependent. As we can see, the bus transportation is of course efficient in the urban areas where you have a lot of people inside the buses, so the emissions per person are low. But then in the not that dense areas, not in the urban areas, in the land side, in the countryside, so bus transportation is of course not that efficient, because then the pollutions per person, if there is not that many people, so it's much higher. So it does say sometimes car is even more environmental friendly. And then, of course, this picture is changing when we are taking into account electrical cars and all those. So this is only for the traditional transportation. Well, buildings, they are the most important part of this urban and pollutions. So if we think about just something, where we are on the path. So the red column shows that buildings in the 1950s, the energy use is rather high. Now we are somewhere with the low energy buildings. Now in the new buildings, the building code level is somewhere there. And we are aiming on those close to zero energy buildings by 2020. So what we did in our new building code, so we have been traditionally focusing on saving energy and especially saving heating energy for space heating. That's of course really important in our climate. But now we have been more focusing also from other energies as well, and also that what kind of energy we are using in the building. So not only putting the reduction of energy consumption, but only taking into account what kind of energy we use. We also traditionally we have been legislating and having building codes for certain heat losses or having certain values, how much insulation you should have in the walls. And that has been really effective in our buildings and shown us results. And now it was time to move on and actually to control more on the total energy use. So meaning that we take all the important factors into account, and giving also more freedom to design that, well, you can choose what kind of methods you want to use. Why we did this was that if we see this, so basically we have been controlling by building code this red bar, which is of course important and has been important. But by now we are actually in this situation where the space heating is already rather, we have cut down those losses, and now the domestic hot water and electricity are becoming more and more important. So that's why we choose that, well, it's good to have, instead of only have the building code for this part, to have the code for the whole part in order to achieve our goals. So the new code has the criteria for the total energy use called E-energy, which includes certain factors for different energy sources. And the aim is to guide towards efficient energy sources and renewables, the use of renewables. And that kind of thinking rewards good architecture and innovation in energy-saving technology. And of course, since we don't know about the future, so we wanted to have the different possibilities to have the open for those. Just to give you a short example, what is the future code? So we say that, well, if you need to port your building, heating 100 kilowatt hours and electricity 15, and you decide to take district heating, so the energy factor for that is 0.7 and electricity 1.7, which ends up the total number of 155 kilowatt hours per square meter. And we have, depending on the building type, so we have certain limit values which you cannot go over. Then it's not only the new buildings, but also the existing buildings which are important. Now, if we think today, so the share of new buildings is rather small, but in 2050, so actually the buildings which we are building today or after today, so the share of those are 50% of our building stock. So that's why it's important that we do right decisions in the new buildings, but also that we do the renovation in a proper way. Well, renovation is of course much more challenging than new buildings, and but on the other hand, we have rather big amount of buildings which are built in the 70s, and they have rather similar technologies there. And the good thing in those 70s buildings, which are maybe not that beautiful today, but they don't have load-bearing facades, and sometimes actually we could have systems that we could renovate those facades up to passive house standards, so really energy efficient, low energy buildings. And also, of course, also upgrading the facade and the atmosphere of that area. As by 2020, we should have the all buildings close to zero energy buildings, so that means that we need to have really energy efficient buildings, renewables, and also when we are using renewables, so that ends up to smart storage systems and smart networks for the energy. Well, is then the zero energy buildings here in the north, is that possible? Well, we have already many pilots actually. Here's a few pilots. We have also here in Tampere many pilots in the housing fair area. So we have seen that this is possible. It's not like impossible or space technology, but actually rather just making things right. But also to think that, well, when we have the renewable energy generation, so it's not anymore the building we should optimize, but also like the wider scope, the area. So what kind of districts we should take into account, and what kind of energy change we should have between buildings and power plants, and where is the optimum there. And there it comes to intelligent networks for heat and cool and electricity. Energy peaks are becoming more and more important, because that's especially when we are having renewable energy sources, so the peaks are not that easy to cover with renewables. And that's why we should also work with that, how we can shave those peaks away. We have especially typically in Finland peaks in the morning, in the afternoon, and then in the evening. So how we can do that with intelligent control systems, storage systems, and influencing on people's behavior. So changing the idea towards the city-level concept, city-level systems, and district-level systems. This is just an example on China, where we have concepts for eco-cities in new areas, but also in the Russia now we have existing areas renovating towards really low energy and low pollution areas. Then another really important thing is the users and to give information to users. And one good example is energy certificates and different environmental ratings. And the good thing is that, for example, energy certification gives the value for the technical performance of the buildings. So it's like calculated value giving you the potential of what this building has. And then of course there is the other part, users who should also have the information and how they could save their energy. So just to give you the example, these are similar buildings, office buildings, built in the same year, and they have similar energy certificates, so it's the same number in energy certificates. But when we see the measured results, which is influenced by the users and their energy use, so we see that there is a lot of deviations, so both in the heating and electricity. And that's why it's good that we have both, that we have the performance of the building, so meaning the certificate, but also that we have the measured value telling the users that, well, now you are going over or under certain limit values, and what kind of information you need and what kind of actions you should do in order to save your energy. and according to newer studies, so the importance of users in the energy use, it can be plus minus 45%. So that's really a big share of energy. So that's why we should not neglect those, the importance of those, and that's becoming more and more important. So it's important that we inform people how these technical devices are working, and also that they can reach those control units and they know where they are located, which was not in the case of this building. And as a last, I have been speaking quite a lot about kilowatt hours and emissions and CO2 and everything, those kind of environmental pressure and natural resources and cost, like those hardcore numbers, which are of course easy for me as an engineer. But when we think about the eco-efficiency, so it's not only this minimizing those numbers, but also the quality. Because if we fail on the quality, so we are not really ending up to anywhere. So that's why it's important that we reward more the quality issues and for the building and for the area. And then we give limits and guides and building codes for the environmental loads and cost and energy use. Thank you.
Thank you, Miimu.